Today, we're going to talk about Unit 7, Day 4, Rhombi and Squares. Today's objective, we will identify the properties of a rhombus and a square. I will apply the properties to find segment lengths and angle measures in rhombi and squares. A rhombus is a parallelogram with all sides congruent. Because the rhombus is a parallelogram, it has all the properties of a parallelogram. Opposite sides are parallel and congruent. Opposite angles are congruent. Consecutive angles are supplementary. Diagonals bisect each other. Take 2 minutes to add to these shapes to show the given properties. All right, let's see what I should have added. For the first one, opposite sides are parallel and congruent. You should have matching triangles and tick marks on opposite sides. For the second one, opposite angles are congruent. You should have matching arc marks on the opposite angles. For the third one, consecutive angles are supplementary. There are two different approaches you could take. You could remind yourself that on each side, the two angles will add to 180 degrees. Or you could give each angle a variable and remind yourself that A plus B, the two angles at the top, add to 180. B plus C, the two angles on the right, add to 180. C plus D, the two angles on the bottom, add to 180. And D plus A, the two angles on the left, add to 180. Both options are just as good. For the last one, diagonals bisect each other. We should have drawn in our diagonals and put different pairs of matching tick marks. Because remember, the diagonals do not have to be equal to each other in a parallelogram. So what makes the rhombus unique? Properties that are unique to a rhombus are 1, all the sides are congruent. 2, the diagonals are perpendicular. Remember, that means that our diagonals will intersect at a 90-degree right angle. 3, the diagonals bisect the vertex angles. This is the first time we have talked about the diagonals affecting an angle. When I draw this first diagonal in, it's going to divide this one angle into two congruent angles. Because angles across from each other in parallelograms are congruent, the two angles across from these two are also the same measure. That's true for both sets of angles. However, because the angles adjacent to each other or consecutive to each other don't have to be the same, they have to be supplementary. These two angles that I marked with the double arcs in pink will be congruent to the two angles at the bottom marked in double arcs, but not necessarily to the angles on the left and the right side. Let's see if we can find all the variables in this figure. When I find A, I can see that A is on the left side of this rhombus. And I also see that this rhombus has a side length at the top of 5 inches. So that tells me that A has to be 5 inches. B is also a side length, so B will also be 5 inches. And C is also a side length, so C will be 5 inches. D. If we look in our figure, we can see that D is this half diagonal right here. That means it is going to be the same as the other half of the diagonal. So D will be 3. Remember, your diagonals are bisected by each other. E is at this angle here in the center. One of the properties that we just went over for a rhombus is that the diagonals are perpendicular. So I know that E is a 90-degree angle. F. F is this half of this diagonal. Remember, your two diagonals do not have to be equal to each other, so it is not necessarily the same as this other half diagonal here. They are not necessarily the same. However, remember we spent a long time working with triangles, right triangles in particular. When I look at this right triangle that has a side length of 3 and a side length of 5, where 5 is the hypotenuse, and I want to find F, I'm going to apply the Pythagorean theorem because I know two sides and I want to find the third side. F in this situation is not the hypotenuse, it is the leg. So when I do the Pythagorean theorem shortcut using the square root, I know if I'm finding a leg I want to subtract in my square root, then my two sides go in squared, where the bigger one goes in first. When I put this in my calculator or work this out by hand, I will get the value for F is 4 units. So F equals 4 units. G. G is this angle that is also here where my two diagonals intersect. So I know it will also be a 90-degree angle. H. H is the other piece, the other half of this longer diagonal. So it will match F, which has a value of 4. I don't have an I in my figure, so we'll skip to J. J is this angle up here, and we just learned in the last slide that one of the properties of a rhombus is that the diagonal bisects the angle. So this angle is the same as the one right next to it that's adjacent to it. So angle J is 53 degrees. Because opposite angles are congruent, when I come down here to find angle K and angle M, I know they will be the same as the angles across from them. so K will be 53 degrees. We don't have an L in our picture. M is 53 degrees. Now we'll move up here to the upper right-hand corner and focus our attention to N. For N, I have another piece of an angle. These are not going to necessarily be the same because my 4 angles in my rhombus are not the same. But this angle here, N, I do know is part of this triangle. And in this triangle, I have a right angle at E, and I have a given 53-degree angle. So if I look at the number of degrees I've already used for this triangle, I've got 53 plus 90. I've used 143 degrees of the whole triangle, which is 180. When I subtract the degrees I've already used from 180, I can see that angle N must be 37 degrees. The diagonals bisect the angles in a rhombus, so these two angles, N and P, will be the same. So angle P is also 37. There was not a variable for O. We skipped it. All right. There is also not a Q, so we will skip to R. R and S are across from N and P, so they will both be 37 degrees. Those are all of our variables. We have completely solved this rhombus. We have all the side lengths and all the angles labeled. Let's move on to a square. The square is a parallelogram that is both a rectangle and a rhombus. So because the square is a parallelogram, just like the rectangle and just like the rhombus, it will have all of the properties of the parallelogram. Opposite sides will be parallel and congruent. Opposite angles are congruent. Consecutive angles are supplementary. And diagonals bisect each other. So these will be labeled just as they were when we first started talking about the rhombus. My opposite sides are parallel and congruent. My opposite angles are congruent. My consecutive angles are supplementary. Remember, we can write it like this, or we could write it like this. And diagonals will bisect each other. And in these figures, I happen to have rhombi drawn, but these are true for all of the squares that are in your notes. Because the square, in addition to being a parallelogram, is a rectangle, it's going to have the properties that we learned yesterday of the rectangles, which are consecutive sides are perpendicular, so they're all 90-degree angles. And diagonals are congruent. So when those diagonals are drawn in, they divide each other into 4 congruent segments. The square is also a rhombus, so it has those properties that we just discussed about the rhombus. All sides are congruent. Diagonals are perpendicular. And diagonals bisect the angles. In this case, we know that because there's 90-degree angles in the corner, since it's a rectangle, they're bisected into 45 degrees. This is true for both diagonals. The square itself does not have any properties that are unique from the other parallelograms. Here's an example of how you might be asked about a square. MNPQ is a square whose diagonals intersect at A. If PQ equals 3 square roots of 2, find each measure. Let's draw a picture. I'm going to draw a square. I'm going to pick a corner to start with M, and then I need to remember that I have to go around the shape. So I'm going to go clockwise, N, straight down to P, and over to Q. If you have Q and P backwards, you will get incorrect answers. My diagonal of this square intersect at A. If PQ equals 3 square roots of 2, find each measure. So from P to Q, we have 3 square roots of 2. Since it's a square, that means it's a rhombus, and all 4 sides are the same. Also, because it's a rhombus, those diagonals are bisecting those 90-degree angles that it has because it's a rectangle. The diagonals also intersect at 90 degrees. These two properties allow me to know all of the angles in every square. You will always have 90-degree angles at the center of every square, and you will always have 45-degree angles at the corners of every square. These two things will only happen together in a square. Now I still need more sides. I need to know how long my diagonal pieces are. So I'm going to use this triangle to help me. When I look at this triangle, I can see that this triangle is a 45, 45, 90 special right triangle. On our formula chart for 45, 45, 90, we see x, x, x square root of 2, where the x values are the legs. So it's leg, leg, leg square root of 2. We can see our hypotenuse here is 3 square roots of 2. The hypotenuse is the leg square root of 2, so my legs must each be 3. When I refer back to my whole square, that allows me to know for each one, those legs are going to be 3. Let's see now that we've filled in all of our segments and all of our angles, if we can answer 5 through 8. 5 says, how far is it from A to Q? I can easily see in my figure that is 3. 6 says, what is the measure of angle APQ? So from A to P to Q, I can easily see that is 45 degrees. Number 7, the measure of angle MNP. So from M to N to P, I have that whole corner, which is 90 degrees. And from P to M is a whole diagonal. Each half diagonal we found to be 3, so the whole diagonal must be 6. Let's look at the next example. We're going to draw a square with diagonals and find all the angles and all the segments if one side is 4. So here is my square. we're going to draw in the diagonals. And I know one side is 4. You could label any of the sides. If it's a square, that means it's a rhombus, so all my sides are 4. If it's a rhombus, that also means my intersection at the center is perpendicular. Knowing it's a rectangle, my corners are 90 degrees, and it's a rhombus, so those 90 degrees have been divided into 45 and 45. So now again, like in the last picture, I have found everything but my diagonals. I'm going to approach this one a little bit differently. Instead of looking at one of the small triangles, I'm actually going to look at half of the triangle. Because that's still a 45, 45, 90 triangle. But this time my legs are given to me, 4, 4, and the hypotenuse. It's leg, leg, leg square root of 2. So that means this is 4, 4, 4 square root of 2. Now, when I divide out my diagonal, I know I've got 4 square root of 2 that has to be divided into 2 halves of that diagonal. So 4 square root of 2 divided in half, I'm going to have 2 square roots of 2 on each side. That's going to be the case for both diagonals. Now we have found all the angles and all the segments in this square. Our last example, we're going to draw a square with diagonals and find all the angles and segments if a diagonal is 20. Let's draw a square. This diagonal is 20 units long. When I draw in both diagonals, I know that 20 is going to get divided in half. So there's 10 units there and 10 units there. Because it's a rectangle, my diagonals are congruent, so they're both 20, and they've both been divided into 10 and 10. Now, this is a rhombus, so the diagonals intersect at 90-degree angles. The diagonals also divide the angles in the corner in half, and those angles, since it's a rectangle, are 90. When they're divided in half, because it's a rhombus, they're each 45. So now we know our diagonals, we know all of our angles, all we need left are our sides. So I'm going to go back to looking at the small 45, 45, 90 triangle. Notice I always try to find a 45, 45, 90 triangle where I either have legs that are whole numbers, or in that first example of a square, we had a square root of 2, and we made sure to think of that as a hypotenuse. Because that's when we can see our leg, leg, leg square root of 2. I can tell my legs are 10. So it's 10, 10, 10 square root of 2 is the side of this square. If that's one side, then that's all the sides. We have found all the angles and all the segments in this square. So just as a review of our objective today, we identified the properties of a rhombus and a square. Your goal is to be able to apply the properties to find segment lengths and angle measures in rhombi and squares. You can show me that you are able to do that by completing the independent practice 7.4, which will be due tomorrow. Thank you so much for watching.